Another derivative. Oh no. Look, there's an outside, the square. There's an inside, the cotangent. We must use the chain rule. The derivative of y with respect to x, we'll take that power, put it out front, subtract 1 from the power, but I don't need to say that. Okay, that's for the outside. But the inside is cotangent, and the derivative of cotangent is negative cosecant squared. Okay. Now if I simplify, I've got a positive times a negative. That 2 times negative 1 is negative 2. I have cotangent x times cosecant squared x. Okay, very nice. That's our derivative. Could we make this moment last? Well, sure, we could make it last. We could say, oh, do we know anything about this? Maybe I would be this clever. Maybe I wouldn't. If I am, well, I recall that cosecant squared is the same as 1 plus the cotangent squared. We've got that rule that looks like I caught a cosecant. Now then, I'd have negative 2 times the cotangent of some angle times the quantity 1 plus the cotangent squared of the angle. Now I could distribute. If I did, I'd have negative 2 cotangent x times 1 and negative 2 cotangent x times cotangent squared to make cotangent cubed. Would I be this clever? I don't know. Maybe not so much. Maybe I would have stopped here. Negative 2 cotangent cosecant squared. Okay, the end.